Do you guys have a CR-10S Pro and you're tired of dealing with that really crappy ABL sensor they include? Well, so am I. So I'm going to show you guys how to get rid of this and put the EZABL Pro on your printer so you can actually get back to printing instead of screwing around with that terrible sensor that comes out of the printer. I've got all the upgrade parts here that we need to connect the EZABL to the CR-10S Pro. We've got a couple of parts here that are in addition to the kit itself. So this is our standard kit with the sensor, the control box, power wire, and the zip ties. In addition to that, for the CR-10S Pro, you also need our signal cable clips, and you can either get these from our store or we have the STL available if you want to print your own. And then the bypass jumpers. We do include 2, even though you only need 1, just in case you lose one or you need an extra for some reason in the future. So in the EZABL kit, we're going to go ahead and open this up. And there will be multiple packages inside this package. We have our sensor with zip ties, the control box with power wire, and also in the sensor package is the adjustment screwdriver that you can use to adjust the sensitivity on the probe here, as well as this will fit the screw terminals for our control board as well. So I recommend you use this so that way you don't strip either the control adjustment out or the screw terminals on the board. So the first thing we're going to need to do is remove the stock shroud from the hot end, and this will use a 2mm hex wrench to do that. There are a total of 2 screws you need to remove to get the shroud off. There's one here and one to the right of your PTFE tube. Now the fan shroud is loose, we can go ahead and move it out of the way. Before we do that, I would recommend clipping this zip tie and then pull this wire sheath back a little bit so we get more room to work. Now to remove the factory sensor, there are 2 screws on the left-hand side here. So we need to back those out to loosen up and release the stock sensor. So these 2 grub screws hold the sensor in. I'm using a 1.5mm hex wrench, and we're just going to back these out a couple of turns. And now as you can see, the sensor is free and we can pull it out. So now we have the sensor wire out, we're going to want to disconnect it from the board back here, and then we're going to pull the wire through the sheathing to completely remove this sensor. Now on this printer, if you haven't previously taken this cover off, there's a screw here, here, and one right here that holds the factory cover in place. I actually had this removed for a while and I'm not quite sure where it is, so that's why mine doesn't have one. But we need to disconnect this wire right here. And there's a little locking tab. So if you put your finger on the side closest to the stepper motor and push, you can then pull down and get the sensor disconnected. You're going to need to clip these 2 zip ties to free up this harness. And take this little twisty thing off. Now if we pull back the mesh, we can now pull the cable out of the loom. Now you see this is getting hung up on here. Just push it in with your finger and get it past the end of the braiding here. Once it's inside here, you'll be able to pull it out pretty easy. And just like that, we have the stock sensor removed. So before we proceed further with the installation, we need to bypass the stock circuitry that ran their probe. So if we look here, you'll see this is where the original probe connected. So place the jumper over the first 2 pins on that header. And just make sure that that's pressed all the way onto the pins. And that's it. There's our bypass jumper installed. Using the included zip ties, go ahead and straighten this out again and put 2 new zip ties where we took them off. At this point, you can now put the factory cover back on. Now that we have the stock sensor removed, it's time to install our sensor. Since this stock mount has screws to retain this, we're going to take off the plastic nuts that come with our sensor. And when we mount the new sensor, we want the sensor to be 2 millimeters higher than the nozzle. So I'm going to move my Z down by hand until my nozzle's on the bed. Now, if you're like me and you have filament on your nozzle, go ahead and try to get as much of that off as you can. Having filament on the nozzle will make additional distance between the nozzle and the bed, which could result in inaccuracies once we get everything set up. So my nozzle's on the bed, and the easiest way to set the probe height is take your wrench that comes with the printer, put it underneath where the probe is going to go, and let it rest on the wrench. Go ahead and gently tighten the grub screws to secure the sensor. And just give it a little tug to make sure it's in there all the way. Now the next step is to route our sensor wire. So take the little twist tie off, and we're going to route the sensor and the existing hot end wires with the PTFE tube. You can use the included zip ties to do this. Replace the zip tie that we took off earlier. And when you route your sensor wire, you want to leave a little bit of slack so we don't damage the wire. What I recommend you do is just make a little loop just like this, and then secure it with a zip tie. So now we have some slack here, so the wire isn't actually straining right at the end of the sensor. You do not want to have the zip ties over tightened. If you see here, I can still move it a little bit, and that's what you want. Do not crank them down. Now we're going to tie the rest of the wires with the PTFE tube all the way back. Now if we look here, the PTFE tube starts going this direction towards the extruder. So I'm not going to put any more zip ties on this. I am going to zip tie my new sensor wire with the braided wires that go back to the breakout board. Now what we want to do is raise our Z all the way up to the top, because we're going to use the cable clips to secure the sensor wire to the stock ribbon cable. Okay, so I have my Z almost all the way to the top. The ribbon cable clips work like this. Put your finger on the front of the ribbon cable and push in. Then slide the clip over and flatten it out. Now we can clip our new sensor wire into the cable. Once the cable is in here, take a zip tie, put it through the back, and come over it diagonally, and this will hold the cable into the clip. Repeat this all the way down. So as you can see here, I have my cable clips installed with the cable running all the way down. I use a total of 5 cable clips to secure this to the ribbon, and you can see it flexes nicely. For the sake of time, I'm not going to show removing the bottom panel, but just in case you guys didn't see the LCD video, there's 2 screws on the left and right side, and then 12 screws on the bottom. So I'm going to take the panel off and show you guys how to install the control board for the sensor. I have the bottom cover removed, and you can see I already have my 12864 LCD installed, which is required to do this upgrade. So if you guys haven't watched that video already, click the link that's in the video description to see how to change the LCD. What we need to do is connect our signal wire for the EZABL to our Z- header, which is right here below the one for our Y end stop. So to do that, we're just going to plug the cable in, just like that. The next thing we need to do is route our sensor wire inside the control box. To do this, loosen up this top screw here and then completely remove this screw here. Now with this plate loosened up, you can see it's free to move about. So slide your EZABL wire underneath the bracket and pull it through. Once it's pulled through, you're going to want to route it down, just like this, and then put the screw back in. And then tighten up the top screw. Now, if we give a tug on the sensor wire, it shouldn't move, and the ribbon cable should not move at all. Now we need to power the new ABL kit. I'm going to pull our power input off the main terminal, and if you guys remove these wires and find that they are tinned, I'd highly recommend you cut the ends off and strip them, because tinned wires can cause these connectors to burn up. Now, if you notice here, I've already stripped these wires of the tinned end when I did the live stream on this machine. So I'm just going to strip the wire that's included with the EZABL kit and connect it with these. Depending on what we had in stock when we packaged the kits, you'll either get solid wire or stranded. If you have stranded, you can go ahead and wrap around with these and then insert them into the terminals. But since I have solid wire here, I'm going to put the stranded wire in and then slide this in after I insert the stock stranded wire. Now that I have the additional power wire in, I'm going to tighten the terminals down again. Give a little tug on the wires, make sure that they're not coming out. There we go, we have our power for our EZABL kit. Now we should have 3 wires total going to our ABL kit. Our signal wire for the motherboard, the sensor cable itself, and the power wire. And we include a very long wire, so go ahead and cut this to the length we're going to need. And I recommend just putting our ABL board right here. So I'm going to cut this right about here and then strip the wires. These wires do usually have some sort of strain relief built into them. I recommend cutting this off so it doesn't get in the way during the installation. And if you can see here, I only stripped off a little bit. We don't need a ton of wire exposed to go into the terminals. Go ahead and loosen up the screw terminals here. And insert your wires. Red is going to be positive, black is going to be negative. And the wires should be all the way into the terminals here. Go ahead and tighten these down. Give them a little tug. You can see they're not coming out, so that's good. All I need to do now is plug in our signal wire. And our sensor wire. For this particular printer, the switch should be in the up position. Take your signal wire and put it in the little cutout right here and slide the lid on until it snaps. And that's it. The kit's connected. You can go ahead and stash the control box between the power supply and the rail here. If you don't want to stash your control box and you got the LCD conversion kit from us, we actually include an extra M3x8 screw. You can take this bottom screw out here, take the M3x8 screw that was included with the LCD kit, because there will be an extra, Put it through the top hole here, and then thread this into the hole where we took the original screw from. The control box is now securely installed inside the printer. I would recommend just doing some cable management and just take these 2 wires and zip tie them together. At this point, we're now done in the control box, and you can put the bottom cover back on. So I've got the bottom back on the machine. The next thing to do is update the firmware to tell it that we're using the EZABL Pro instead of the stock bed leveling sensor. So let's go ahead and plug this into our computer. We're gonna use the same firmware that we used in the video to install the LCD, except we're going to comment out one of those options that tells it what type of probe it is, and I'll show you how to do that right now. So this is going to assume that you guys followed the LCD installation video and you already have this firmware downloaded on your computer. To set up your printer to use the EZABL instead of the stock probe, we're going to need to make one change to the firmware. So let's go ahead and load it up. Now that we're in the firmware, you're going to want to make sure that your COM port is selected for the printer. My printer in this case is on COM 58. Make sure your board is the Arduino Mega 2560. And the processor is the AT Mega 2560. So go ahead and click the configuration.h tab, press Control F or Command F if you're on a Mac, and type CR-10S_Pro and hit enter. As you can see here from the previous video, I already have the options uncommented for the CR-10S Pro with the stock bed leveling sensor. If you guys are doing the LCD and the EZABL installation in all one go, the firmware is going to look like this with everything commented out. So if you're using the CR-10S Pro with the EZABL sensor like we are right now, you're going to need to uncomment 3 lines of code. Uncommenting means removing the 2 slashes in front of these define statements. So the first one to uncomment is define CR-10S Pro, define RRLCD upgrade, and CR-10S Pro OEM. Since we're using the EZABL, we do not uncomment the CR-10S Pro stock ABL line. If you uncomment this line, it will not work correctly, and you will need to comment it out, meaning adding the 2 backslashes in, just like that. I'm going to do a Control S to save my file, and all we have to do now is hit upload. At this point, your computer will compile the firmware and upload it to the printer. Make sure all slicers are closed, because if you have a slicer open, it's going to probably be connected to the COM port, and it's going to deny the Arduino access to actually program the printer over the COM port. I'm going to let this upload, and I'll be right back. Now that we've got the firmware updated, what we want to do is move our probe to the center of the bed, like you see here. Move your fan shroud out of the way, and move it down until the nozzle touches the bed. Now our nozzle's on the bed. Press the button on the screen. Go to prepare. Move axes. Move Z. Move 1 millimeter. And move it up 2 millimeters. What we're going to do now is calibrate the probe. It's recommended to heat your printer up to the normal print temperature, but only on the bed. So go back to prepare. And we have presets for PLA and ABS. The PLA preset, if we go to PLA bed, is going to be 60C. So I'll let this heat up and then we'll come right back to calibrate the sensor. Now I've let the printer sit at temperature for about 5 minutes, and now we can calibrate the probe. To do this, it's a little trickier since this stock mount doesn't provide us access to the adjustment screw. So loosen up the grub screws, just enough so we can pull the sensor up. Now, since we made this nice little loop here, it kind of supports the sensor. When we mount the sensor and calibrate it, we want the top of the black housing to be flush with the top of the aluminum part that mounts the sensor. As you can see here, my probe already has the red light on, which means it's triggered. If yours is green, you can ignore the step here where I'm going to turn down the sensitivity. To turn down the sensitivity, turn the adjustment counterclockwise. Put it back into the mount and see if it stays green. If it stays green, we can now go ahead and adjust this to the correct trigger distance. What we want to see is when the black portion of the sensor is flush with the top of this mount, the light should be red. And I'm turning this clockwise, just a little bit each time. You can see here the sensor triggers when the top of this is flush. And that's exactly where I want it. Once you have the sensor calibrated, go ahead and secure it with the grub screws on the mount. Do not over tighten these. You just need to make sure that when you pull on the probe, it doesn't move. At this point, we can now reinstall the fan shroud, and the easiest way is to slip it over the top and drop it down like that, and then put the 2 screws we took out earlier back in. Now, if for some reason you do need to recalibrate your sensor, Creality does have 2 access holes here for the grub screws. You will just have to pull it out a little more and you're not going to be able to see it as easily, but it's still possible to adjust the sensor once this is on. So make sure your wires are all tucked in and that you didn't pinch anything. And I just ran an M48 test and I'm getting 0.003 millimeters of accuracy with this, which is great. If your M48 result is under 0.01, then your probe is properly calibrated. So at this point, I'm actually ready to set my Z offset, and all that means is we need to go to Prepare, Auto Home, and if we go back out of the menu, you'll see our Z shows 5. This is not included in your offset, so I'm going to go ahead and go to Prepare, Move Axis, Move Z, and press Move 1, and we're going to zero that out. Now that that's zeroed out, you can press the button to exit, go back up to Move Axis, Prepare, Main, and we're going to go to Control now. Go to Motion, Probe Z Offset, and now we need to grab a piece of paper. Personally, I found a business card works really well for leveling, so I'm going to use that. And now we're going to set our Z offset. I'm just moving the knob counterclockwise until it starts to grab my card. And we should have an offset of around 2 millimeters, which is what I have here. So press the button again, go back to Control, and hit Store Settings. Go to Main, Prepare, and press Auto Home. So now our axes are homed again. So if we go back to the main menu and get back to our status screen, we can see Z is at 5 again. Except this time, when I go to Prepare, Move Axis, Move Z, Move 1, if I put my piece of paper back under and move it down 5. It's grabbing the paper just like it was. So my Z offset is now set and I can begin printing. So right now I have my Z motors engaged and I'm actually purging out some old filament right now. So I'm waiting for this to purge. I'm going to check to make sure my gantry is level on either side. You can print leveling blocks, which are available in our firmware pack and on Thingiverse, or if you have a pair of calipers, you can go ahead and measure it with that. And it's important to note you're measuring from the printer frame, not from the bed. So I'm at 134.28 on this side and 135.48 on this side. So I'm about 1 millimeter off. I'm just going to grab my lead screw coupler here and bring this down until I'm within 1 millimeter. And this is something you'll want to check. You typically do not want to have more than 1 millimeter between this side and this side because the sensor is a bed leveling sensor. It cannot compensate with the software and the readings to know how far out of level your gantry is with the printer's frame. So I've got my filament loaded, my Z offset set, and the bed is relatively level. My gantry is level with the frame, and I've updated my starting code in my slicer to the one that's included with the EZABL kit. At this point, I'm ready to start a print, so I'm going to show you guys how to use the live Z adjustment in case you need to make any adjustments during the first layer in real time. So when you start a print, the printer is going to home, X, Y, and Z. After that, it's going to take measurements on the bed. And now it's going to wait for the heaters to get back to temperature. With our starting code, you'll see it do a purge line over here on the left. And then it will begin its print. Now my first layer is looking pretty good, but just so I can show you guys how to use the live Z adjustment, I'm going to mess with it. So if I press the button twice, you'll get probe Z offset on the screen. At this point, you can make it closer to the bed by turning it counterclockwise, or further from the bed by turning it clockwise. This is a really helpful feature because depending on your machine and the mechanicals of it, you might have to adjust this during your first layer. As you can see here, I'm actually running a skirt around my print so I can perform my adjustment on the skirt and not my actual printed part. So I'm going to let this finish the bed level test, and I'm actually going to squish it a little bit more, which I can do by just turning the knob here. Now, if you find you're consistently having to use the live Z adjustment here, or baby stepping as it's also referred to, and it's the same amount, you can go ahead and press the button, press it again, go to Control, and then Store Settings. Once you hear that confirmation beep, that means it's stored the changes, and it will retain those changes on the next startup of the printer. So I'll let this go ahead and do the bed leveling test, and we'll come back and see the result. Okay, so our first print completed successfully. You can see here, we got nice even extrusion here. This little corner here is where it started feeding, so it under extruded a little. You can see where I started here, before I adjusted it with the live adjustment, it was a little high. This also could be caused by the probe being close to this metal clip here, and there is a setting in the firmware that you can adjust to have it probe further in on the bed. It's called the probe edge setting, and that's under the EZABL advanced configuration options. Let's go ahead and take a look at the other spots. We're looking good in this corner and in the center here. We got our lines here, they're stuck down. The corners are looking good as well. So we're all ready to go, and this machine's now ready to print. We got the EZABL Pro installed on our CR-10S Pro. We got bed leveling working. We got rid of the touch LCD. And I'm pretty happy to say that this printer's finally up to my standards, and it's gonna go in our print farm now. So if you guys wanna go ahead and upgrade your CR-10S Pro and get rid of that god-awful sensor that comes with the machine, you can go ahead and click the links in the video description below. I've got a couple of different packages for you guys. There's one that's just the LCD kit. There's one that's just the EZABL kit. So if you've already added the LCD on through our guides or other guides on the internet and you want to convert the sensor, we have just that. And there's an all-in-one package that includes the LCD and the EZABL conversion. If you do already have an EZABL kit, the EZABL Pro is fully compatible with the CR-10S Pro. You'll just need to pick up a couple of extra pieces like the bypass jumper, the signal cable, and the cable clips. So if you guys have any questions on what you should order, you can go ahead and shoot us an email by emailing support@th3dstudio.com, or you can click the contact us link at the top of the page. Or if you prefer to talk to somebody on the phone during our normal business hours, you can actually call us at 312-858-TH3D, and you can press option 1, that's our sales line, and that's during our normal hours, which are Monday through Friday, 9 a.m. to 5 p.m. Central Standard Time. I'm really happy to bring this upgrade to you guys. I really hope everybody enjoys it. I know I'm gonna be putting a lot more time on this machine now that it's actually working correctly. I generally try to get their sensor working and tuning it and doing firmware changes, but the reality seems to be that their choice of sensor and or the other hardware driving the sensor just isn't really up to the task. I'm actually recording this video a couple days after shooting the installation video part that you guys saw, and I can tell you it's been just a breeze to use at this point, and the machine is in our print farm now making useful parts for our products and our customers. I also wanted to throw in that I wanted to apologize for how weird the audio was in this video. I didn't realize until after recording the entire thing that the levels on my mic were way too low, so I had to go run the audio through a processor afterwards to try to make best use of it. I will be checking my audio in future videos. I just want to throw this in here because I know there's going to be people commenting in the comments complaining about the audio. The alternative would be to reshoot the entire thing, and I just simply lack the time right now to do that. I will see you guys all later. Thanks for watching, and as always, happy printing.